Okay, so let's do problem 515 here. And I have the diagram pulled up here in the upper right hand corner. And what we're looking to find on this diagram is the reactions at the supports here. So the reactions at the supports, so that's A and B on both ends. At point A, we have a fixed support here. So we know that the reactions at A, we're going to have an AY component, and we're also going to have AX. I'm just going to draw AX in the positive X direction. If it ends up being a negative number, we know that this will point in the opposite direction. And at B here, we have a rocker support. And the rocker cannot support any loading in the X direction here, but it can support in the Y direction. So at B here, we just have a vertical component, BY. Okay, so I have the diagram sketched out here as a free body diagram. I'm just going to add our AY, AX, and BY components right on the diagram here. All right, so we know that this problem is in equilibrium. Okay, and what does that mean? Well, we know that the sum of the forces in the y direction are going to be equal to 0. Sum of the forces in the x direction are going to be 0, as well as any moments around any point we know are going to be 0. So we could start out by just simply doing the sum of the forces in the x direction, and we'll get an answer that way. So let's start there. Sum of the forces in the x direction, set those equal to 0. So what do we have in the x direction? We have AX, right? That's 1. So we have AX pointed in the positive x direction. And we have 5 kilonewtons up here on the top pointed in the positive x direction. So we have AX plus 5 equals 0. All right? That's a simple one. So we have AX is equal to 5 kilonewtons. All right? So that's one part of the answer here. Okay, and since it's negative, that just means that it is, from how we've drawn it, it's actually 5 kilonewtons in the opposite direction. Okay, so let's continue on here. Now, we could sum the forces in the y direction now and set those equal to 0. But if we do that, you may be able to see that we have AY and BY both pointed in the y direction here. So we'll have two unknowns. We don't know AY and we don't know BY. So we'll have two unknowns in one equation, which doesn't make that directly solvable. But we could continue down that route if we wanted to, but I think there's an easier way to make this directly solvable. So if we take the moments around point A, and we know that those have to be equal to 0 due to equilibrium, right? So the moments around A, if we do that, we know A, Y, and AX both go through point A. So they're not going to create a moment about A, okay? So those are not going to create a moment about A. So then really the only unknown force that we have in this equation is By, which then we have one equation, one unknown. It's directly solvable. So I'm going to say our positive sign convention is counterclockwise here like we normally do. And let's just start with this. Okay, so we'll work around accounting for each of the moments caused by each of the forces here. So we have the 6 kilonewton force acting at a perpendicular distance of 2 meters away. All right, and this is going to cause a clockwise motion around point A. So that's going to be negative based on our sign convention. So we have negative 6 times 2 meters away. Now we have this 8 kilonewton force that we need to account for. And like the 6 kilonewton force, it's going to create a clockwise moment, which is also going to be negative. So we have 8. And the distance it is acting away from A is 2 plus 2, which is 4 meters. And then we have By, which is going to create a counterclockwise moment, which is going to be a positive sign convention. So we have By and the perpendicular distance that it acts away is 2 plus 2 plus 2, which is 6 meters. And lastly, we need to account for this 5 kilonewton force on the top here. Now this 5 kilonewton force is going to create a clockwise moment here. So that's going to be 5. And the perpendicular distance, right? So the distance here, or the force is pointed to the right here. So the perpendicular distance is actually this vertical distance here, which is given on our diagram as 2 meters. Okay? And that accounts for all the forces on our diagram. So we set that equal to 0, and then we can solve for By. Now By comes out to be, let's see here, By comes out to be 9 kilonewtons. Right? And that's part of our answer, so let's circle that. Okay, the only unknown that we haven't solved for is Ay, okay, Ay here, right? So we're going to have 6, 8 and, downward, and then Ay plus By upward. So let's write that equation. So we're going to have, let's see, so what did I say? We have -6 minus 8, those are the downward forces, plus By plus Ay is equal to 0. We know By is 9 kilonewtons, so we can put that in here, and we come out with Ay then equal to 5 kilonewtons upward. So that's positive, so we know it's pointed upwards. Okay. And we have solved for all the reaction forces here. Everything's in equilibrium, and that is the solution to problem 515.